In this lesson on Java algorithms, we will learn about another sorting algorithm, which is insertion sort. So what is insertion sort? As the name suggests, it gets its name from insertion, which is we keep on inserting the element at the right position. So we will start from the left and keep on maintaining a sorted list, and the next element that we pick up, we will just insert it into this sorted list so that it remains sorted. One way to visualize it is that if we have a set of cards in our hand when we are playing cards, what do we do? How do we sort it? We keep on sorting one card at a time and keep on inserting it into the left part of the hand, which is sorted. So let's look at an example to try and understand it better. So we have this group of numbers which we want to sort in an ascending order. So let's put the starting array is the set of values 10, 8, 15, 7, 9. And we will start from 1. Why would we start from 1? Because one element is always sorted. So if we have one element, it is always sorted. Now we need to start sorting from the location 1. So this element 8 needs to get sorted. So the value is 8. Now how do we sort it? We know this part of the array which is less than I is sorted, and in this we need to insert 8 so that it will get sorted. Now where should 8 get inserted? 10 comma 8 will not be sorted, so 8 has to get inserted before 10. Okay, so how do we do it here? So the first thing we will do is we will start from this location and see whether this value, we will keep on pushing these values one right till we reach the right location where we need to insert 8. So the first thing we will do is, to this array we know 8 is not 8 is less than 10, so which means we will copy 10 to the right. So this is how our array will look like. Now we will come here and we have reached our first location. So we know either we have reached the first location wherein we need to put the value, or we have reached a value where we need to put it. So now that we have reached it, we will put our right value because we've reached a default case. So which means now this is sorted. So can you see this part of the array has become sorted now. Now let's move to the next iteration. So here we have taken this as the starting array, which is the same array, and now at position 2 we need to sort. And what is the value at position 2? It is 15. So we need to sort this value. So now notice that when we start from here, this value, if it is less than the previous values in the array, we'll keep on pushing them, but this value is more, so we don't need to push it. So we will just copy it in its place. So this remains our sorted array. Our second pass is over. Now we are moving to pass 3. In pass 3, what is our array? The array will look like as it is at the end of pass 2. And now which is the element we need to put in? Which is 7. So 7 needs to be put in. Now how will we put 7? We will keep on pushing these elements one right till we reach the right location for 7, or we reach the start of the array. So now 15 is greater than 7, so we'll push it one right. So how do we push it one right? We will copy it in the right position. So this is how the array will look. Now we will check for 10. Now 10 is greater than 7, which means we will now push it one right. So how will the array look? So this is how the array will look. Now we have come to 8. 8 is also greater than 7, which means it needs to get pushed one right. So how will the array look? So notice at each step what has happened. We started with this array and we have kept on pushing it. And remember, we have not lost this value because we have saved it here. So now because we have reached the start of the array, we will copy this value. So now what will happen is, this is how the array will look like. Now we have copied 7 because we've reached the start of it, and notice this part of the array is now sorted. It is completely sorted now. So that becomes, I becomes now 4, and we will write down our array, a starting array for this step. And now what is the value we want to put insert? It is this value. 9 has not been dealt with so far. So now we need to insert 9 into this array. So we'll start from this position 15. 15 is greater than 9. So we need to push it to the right. So how will we push it? 10, sorry, so 7, 8, 10 and 15 is pushed to the right. So once we push 15 to the right, we will reach here. Now the value we need to check is 10. Is 10 greater than 9? Yes, it is greater than 9. So we will push 10 one right. So how will it look like? Now we have pushed 10 to the right. Now we are at 8. Now 8. Is 8 greater than 9? No, 8 is not greater than 9. Which means 8 will not get pushed to the right. And at this slot we will put 9. So at this slot we will now put 9. So how will the array look like? So you can see now we have the array sorted. So why is it called insertion sort? So like we saw in the last step, we inserted 9 into this sorted array. So this part of the array was sorted, and if we had to insert 9 into it, what would we do? We will push 10 and 15 to the right and insert 9 in. That is exactly what we have done. So in that array, this is exactly what we have done. We pushed them, we created a space for 9 and we inserted 9 into it. So this is why it is known as insertion sort. Let us just look at the algorithm. So for I is equal to 1, I less than len, that is what we did. We picked up the value we need to insert, which is arr I is the value we need to insert, or let's call it ai if the array is known as a. So we have picked up this value which we need to insert, and we are starting from j is equal to I, and we are checking whether j minus 1 is greater than value or not. So we're starting with that and we're checking. So what are we checking? So like in this case, we check whether this value is greater than the value or not. So 15 would be j minus 1. So because j is I, so we will keep on checking it, and if these two conditions are true, we are keep on shifting it. So this is pushing one element right. Aj is equal to aj minus 1 means we're pushing one element right and we are reducing j. So either two things will happen. Either j will become 0 and this while condition will become false, or we will find the slot where we need to put it, because this condition will become false. Aj minus 1 is greater than value, which means we'll get the slot. So this is what happened here. So when we had pushed it here, at this point we looked at the value of aj minus 1, which was 8. Now that was less than 9, so we inserted, so the while loop would have become false. And what then did we do? At that position we inserted value. So now we had inserted 9 there. And in the earlier conditions, so like when we check for 7, what happened? We kept on doing it till j became 0. So this condition here would have become false, and then at the 0th location, because j was 0, we would have inserted the value. So this is how an insertion sort works. And like the other two sorting algorithms that we have studied so far, bubble sort and selection sort, it's a simple sorting algorithm. It is inefficient because it's order n square, and we know efficient sorting algorithms are n log n. Okay.